Okay, so on to our bonus example. For these examples, anytime I do a bonus example, what it means is that I don't necessarily recommend that you follow along with pencil and paper, like I would recommend with the other ones. But these ones, I certainly recommend that you follow along and watch what I'm doing, and watch the work that's being done, and understand every step of the way. Because if you can understand these, it will help you understand smaller examples. So here we go. So we have a large equation here. X plus 1 over x plus 2 minus x plus 3 over x plus 4, all divided by x plus 5 over x plus 6 minus x plus 7 over x plus 8, all equals 1. Holy smokes, how on earth are we going to solve this one? Well, let's just start with the same process as we did with the other ones. Step 1, multiply both sides by the denominator. So it's this huge denominator down here, x plus 5 over x plus 6 minus x plus 7 over x plus 8. This huge denominator, I'm going to multiply the left side and the right side of the equation. What that will allow me to do is go on to step 2 and cancel the denominator on the left side of the equation. So cancel, cancel, which just leaves us with the stuff on top here, x plus 1 over x plus 2 minus x plus 3 over x plus 4, which equals, on the right side of the equation, 1 is just 1, so we got x plus 5 over x plus 6 minus x plus 7 over x plus 8. Step 3. Achieve a common denominator for the entire equation. Notice that we have denominators of x plus 2, x plus 4, x plus 6, and x plus 8. Therefore, we multiply every term by each of these denominators. We have. Oh boy. So, obviously, our task is going to get very demanding, because we have, especially in terms of space. This is why I said maybe consider not doing this one by pencil and paper, because look at how large the work gets. And when you do exams in school, chances are you won't get an example this large. But it's important to understand how these are done, so just sort of watch and follow along. So for the first term, x plus 1, we're going to multiply by, x plus 2, x plus 4, x plus 6, and x plus 8. That's why I have this, this, and this here. And then for our second term, x plus 3 over x plus 4, I'm going to multiply by what? Well, you guessed it, x plus 2 times x plus 4 times x plus 6 times x plus 8. And then for this term, I do the same thing. X plus 2, x plus 4, x plus 6, x plus 8. And for this term, x plus 2, x plus 4, x plus 6, x plus 8. Okay. Wow. So now what do we do? Well, we just simplify wherever possible. So x plus 2 and x plus 2 cancel. X plus 4 and x plus 4 cancel. X plus 6 and x plus 6 cancel. X plus 8 and x plus 8 cancel. So what is that going to leave us with? Well, it's going to leave us with x plus 1 times x plus 4 times x plus 6 times x plus 8. So that's what I put there. And the denominator is gone because it canceled. And then for the second term, we have x plus 3 times x plus 2 times x plus 6 times x plus 8. That's what I have here. Again, the denominator's gone. Same thing for this term. X plus 5, x plus 2, x plus 4, x plus 8. And for the last term, x plus 7, x plus 2, x plus 4, x plus 6. So you get an appreciation for how big the work is if you were to try to do this by hand. You would need multiple lines just to write one equation. Just kind of crazy. But anyhow, we're going to factor this equation. The way we do that is inside the square brackets on the left side of the equation. Notice that this term here has an x plus 6 and an x plus 8. This term over here has an x plus 6 and an x plus 8. So that these two terms share these common factors. So you factor out the factors that they have in common to make the equation looks simpler. So factor out x plus 6, x plus 8, x plus 6, x plus 8. And this is what it looks like. X plus 6 times x plus 8 times the stuff that they didn't have in common, which is x plus 1 times x plus 4 minus x plus 3 times x plus 2. One more time, looking at it. Right, so the first term, if I took these away, I just have x plus 1 times x plus 4. Second term, if I took these away, I just have x plus 3 times x plus 2. Like I just said, x plus 1 times x plus 4 minus x plus 3 times x plus 2. And then this whole square bracket times x plus 6 times x plus 8. And guess what? We get to do this whole process over again on the right side of the equation. So what does this term and this term have in common? This term and this term. Well, it has an x plus 2 and an x plus 4. X plus 2, x plus 4. So it shares these two expressions in common. We can factor out those expressions to get x plus 2 times x plus 4, all multiplied by this big square bracket, x plus 5 times x plus 8 minus x plus 7 times x plus 6. Okay. Alright, so enough about that. Let's go on to our next step. Expand the equation inside the square brackets. Okay, so we have 4 separate quadratic expansions to take care of. The first one is x plus 1 times x plus 4 gives us x squared plus 5x plus 4. The next one, multiply these two elements together to get x squared plus 5x plus 6. Multiply these two together on this side of the equation to get x squared plus 13x plus 40. Multiply these two to get x squared plus 13x plus 42. Now we have this massive equation with quadratics in it. And it may make us feel like we want to cry. Good news is we don't have to, because look at how these simplify. X squared minus x squared is 0. 5x minus 5x is 0. 4 minus 6 is negative 2. So all of this stuff inside the square bracket just becomes negative 2. Same thing happens on the right side of the equation. X squared minus x squared is 0. 13x minus 13x is 0. 40 minus 42 is negative 2. So this looks this right here, this equation on this line looks a lot nicer than all the stuff we were working with before. But then again, we can just divide both sides by negative 2 to get rid of these brackets completely. That cancels, and we're just left with x plus 6 times x plus 8 equals x plus 2 times x plus 4. Step 6, expand the equation. X squared plus 14x plus 48 equals, right, because I just expanded this into this, and then I'm going to expand this into this. X squared plus 6x plus 8 on this side. Simplifying our equation, x squared, subtract from both sides, so that's gone. Subtract 6x from both sides to get 8x, and that's gone. Subtract 8 from both sides to get 40, and that's gone on the right side. So the whole right side becomes 0, and the left side just becomes 8x plus 40. Thus, x equals negative 5. Alright, and I'm going to do this example over again, but this time, I'm going to add a small twist to it. Instead of equaling 1, I'm going to make it equal 5 halves. Now, how is this going to change the way we approach the problem? The answer is it's not going to change our approach at all. It's only going to change a little bit of factoring towards the end of the problem. So, like we've just seen, our approach is the same. Step 1, multiply both sides by the denominator. And we get that. We just have the extra 5 halves hanging around on the right side of the equation. Step 2, cancel the denominator like we did before. Same thing. Step 3, achieve a common denominator for the entire equation. Notice that we have x plus 2, x plus 4, x plus 6, x plus 8 as denominators. Therefore, multiply every term by each of these denominators. And of course, we get this huge, huge mess. Same as last time, except we have 5 halves hanging around on the right side of the equation. Simplifying, again, x plus 2's cancel, x plus 4's cancel, x plus 6's cancel, x plus 8's cancel. And we're left with this. Step 4, factor the equation. X plus 6 and x plus 8 are shared in common on the left side of the equation, so you factor them out. On the right side of the equation, x plus 2 and x plus 4 is shared in common. You factor that out, and you get this equation here. This equals this, which is exactly the same as last time, but the 5 halves is still hanging around. And then on to step 5, expand the equation inside the brackets. Everything looks the same as last time. This expands to this, this expands to this, this expands to this, and this expands to this. Same as last time, just the 5 halves out in front. Simplify. Remember how we had the negative 2 and the negative 2? Well, same thing happens. Simplify further. Okay, so this is where it starts to get just a tiny bit different. Negative 2 cancels with negative 2, that's fine. But then we're going to multiply both sides by 2 to get rid of this denominator, this 2. We're just going to swing it out to this side. So 2 times x plus 6 times x plus 8 equals 5 times x plus 2 times x plus 4. Step 6, expand the equation. So expanding the equation like we did last time, except this time we have an extra multiplier to take into account. So what we end up with is 2x squared plus 28x, right? Because normally this would be x squared, but then you times by 2. This would be 8x plus 6x, which is 14x, but you times it by 2 to get 28x. 6 times 8 is 48, times 2 is 96. On the right side, we have x times x is x squared, times 5 is 5x squared. 4x plus 2x is 6x, times 5 is 30x, and then 4 times 2 is 8, times 5 is 40. So now we have this equation. Simplifying, subtract 2x from the left side and subtract 2x squared and 2x squared. That goes away, that becomes 3x squared. Subtract 28x, that goes away, and this becomes 2x. Subtract 96, that goes away, that becomes negative 56. So it's 0 equals all that stuff, I just flipped it around. So 3x squared plus 2x minus 56 equals 0. And now we have to factor, and this is a more difficult example of factoring. And if you can do factoring like this comfortably, you can do any factoring in the high school level. So basically the way it works is you need two numbers that multiply to 56, first of all. And then you have to try out different combinations until you get 3 times a number plus 1 times another number, adding to give you 2. So it's at the high school level, this is about the most difficult type of example for factoring that you'll ever get. And in this example, what it turns out to be, and I'll do more advanced factoring examples where I get into more detail in another video, but for right now, we're just going to acknowledge that this 3x squared plus 2x minus 56 factors to 3x plus 14 times x minus 4. And when in doubt, you can always experiment. If you're at this stage here and you're stuck and you don't know how to factor it, one of the things you can do is you can try different numbers that are factors of the last term. So negative 56, you can just try different factors. You can try, okay, let's try 1, let's try negative 1, let's try 2, negative 2, 4, negative 4, and so on, until you find something that when you plug it in for x, it gives you 0. And once you've found an answer for that, you can take whatever that number was, the negative version of that, and for example, 4, when you plug in 4 for x, this gives you 0. It works. So that therefore x minus 4 is a factor. And then what you can do is you can take x minus 4 and do a what's called long division or synthetic division if you're comfortable with that. And it will give you the other factor, the 3x plus 14. But for right now, I'm going to end this this video right here. And if you guys want me to do more examples of factoring, I can certainly do that in another video. So our answers here are negative 14/3 and 4 for this problem. Okay, thank you for watching. See you in the next video. Cheers!